Good morning, friends. Today we are going to discuss a new topic, that is a thermal spray deposition techniques. So, in this particular talk, we will discuss about different thermal deposition techniques in detail. So, in last lecture, already I have given the introduction about the thermal spraying. So, in today's lecture, we will see flame spraying, then wire arc spraying, and plasma spraying. So, as I mentioned, there are the wide varieties of the thermal deposition techniques are available in the technique, and these classifications are based on the kinds of heat source you are using for the spraying operation and some other parameters like velocity parameters, then maybe the speed of the coating. So these few parameters are very important to dictate the different, or maybe they act as the driving force, okay, for the classification. So among these all processes, you can see that flame spraying, okay, is the index, and also you can say that most primitive in nature, and also it is quite cheaper also. So first we will go for the flame spray process. So in flame spray deposition process, what you do is that people do use the oxyacetylene fuel as a source of heat for as a fuel for generating the flame, and subsequently is the source of heat. Oh, okay. So ignition of this oxyacetylene flowing is done in flame spraying process. So this technique can use the metal or procure powder in the form of rod, or it can also use it in the form of powder, or it can also use it in the form of wire. So depending on the tip of the precursor powder, you have different kind of nozzle. You have to design the nozzle accordingly. Okay, so if it is your precursor, suppose here in this diagram I have shown the precursor. Okay, if your precursor is in the form of lot, then naturally you have one kind of that nozzle where there is a possibility of inserting the tube continuously, and subsequently it gets impact infest in that, it gets inserted the tip of the flame and gets melted, and subsequently through other part of nozzle there is a flow of luscious pieces. Usually the you flow air, or you can also flow argon or nitrogen as a carrier gas, and the carrier gas is used to just gradient the molten material into the small droplet, and subsequently it is propelled into the surface of the substrate to get the desired coating. uh, it can also be in the form of powder. When it is in the form of powder, then there has to be a powder feeding nozzle. Okay, so look at the second diagram here. When it is in the form of powder, then there should be the powder feeding nozzle. Okay, so here nozzle is there, and through the powder feeder, you basically feed the powder with the carrier gas maybe argon. Then what you do is that you feed it, and then that feed powder is actually flown into the tip of this particular flame, and then that feed powder is actually flowing into the tip of the particular flame, and then it in that flame actually melt the powder, and subsequently the molten metal is again just broken into the small droplet with the help of the air gases, high velocity of that air, or maybe the argon, or maybe the nitrogen, any gases pieces you use, and then it is propelled at the highest speed Okay, and it will impinge on, or it will coat on the surface of this substrate. Okay, so in this case there has to be provision of powder feeder, or so that you get the powder get fed properly into the uh, that flame tip. Okay, and here you have should have provision for ceramic wire, or maybe that typically rod to get into and subsequently get melted and molten is get subsequently spread over the surface. So in this frame spraying operation, your main parameters will be the oxygen to oxygen to acetylene ratio, or maybe the oxygen to propane ratio. What if the powder, or what if the fill you are using for the heat generation, and your another parameter is the powder particle size. Okay, as well as the shape, and also in which form you are using the coating powder, whether it is in the form of rod or it is in the form of wire. And the third parameter is the velocity at which it is spread over the surface of the substrate. So these are the three important coating parameters which plays very important role in the determine the quality of the coating. And final parameter is the substrate pretreatment. What kind of technique treatment has been done on the surface and distance between the nozzle to the substrate. So these parameters we need to consider. Now let us move for the next. Now in this particular flame stream process, you will as I have mentioned already, this process is very much cheaper in nature and versatile in nature, but can be applied for the coating of the low melting uh, and particularly your aluminum, zinc, tin and steel fuel, but it cannot be applied for the depositing of the high melting point material like molybdenum, titanium, or maybe carbide, nitride, aluminite or oxide. So those coating cannot be achieved by flame spray process that can be applied for the deposition of particular metallic metal and particularly low melting metal. And another disadvantage of this process is that uh, this flame spraying operation, you end up with the porosity as high as 8 to 9%. So large number of porosity included in structure. Now let us go for the next one, wire. So this is second type of coating, that is wire arc spraying. So in arc spraying, as I mentioned to you, that it is you are using your arc as a source of heat. So here usually people do is oxy. So people do usually is that arc which is consumable out of the consumable wire. So you have the DC power supply unit and two wire you feed, and then at the contact point you have the arc generation. Okay, so you can see here in this diagram also I have given. So you have two DC power supply unit and the two wire you feed, and then at the point of contact you have arc generation. Okay, so here then you basically use the complex here, or just break the molten material in the form of droplet and subsequently spray over the surface of the substrate here. So this is how the arc spray unit operates. So if you just quickly go through the typical variation in this arc spray deposition, there are the like typical variation are like arc the rate at which here feeding arc, usually the rate which you are feeding, that are arc feeding. Wire for the arc generation has to be optimized, because if the wire feeding rate is higher than the rate at which it is consumed, then you will find that there will no arc which is generated there. Okay, so for generation of the perfect arc and subsequently it's used for melting of the material, your arc speed has to be wire feeding speed and has to be maintained, or has to be, you have, you can say that standardized, so that there is no chance of any problem related to generation of to arc. Okay, and second parameter is that velocity of the air or the inert gas which is used for profiling purpose. So third parameter is the distance between the arc generation and that of the substrate, so that which material you are using to coat. Okay, the thickness of coating is in the range of the 100 to 200, then 2000 micron. And in this coating also powder, you can say that coating poses it's a lot of defect, particularly porosity. So porosity contain varies 10 to 20%, as it's there is in case of the flame spraying. Okay, now this is plasma spraying process. So a little bit advanced of this particular technique is the plasma spraying. So plasma spraying is a little bit advancement in the stage of plasma spraying. You really get the very high heat into the tip of the torch here, as I have shown in the figure. So heat content in the plasma spraying or arc spraying can be in the flame spraying, and arc spraying can be 1500 or 700 degrees Celsius. On the other hand, in this plasma spraying, it can be as high 25,000 to 30,000 degrees Celsius. Okay, this is advantage. So in this particular plasma spraying, what you do is that you basically generate the plasma. Plasma is nothing but cluster of ions and electrons and nuclear atoms. So that particular plasma, whenever it generated, then naturally that plasma is very, it is having very high energy, and depending on the density of the plasma, basically in this particular plasma you generate a lot of plasma densities, lot of ion densities, and because of generation of very high density ions, your temperature also reaches to a very high level. And basically the plasma is generated in between these copper and tungsten electrodes. Okay, so here I have used the electrodes, and very high temperature is generated in this particular torch. You should have the constant cooling arrangement for this particular copper tube also. Okay, so here I have mentioned the cooling system also. So proper cooling has to be done so that there is no damage of the electron, and that plasma heat is used for the heating or melting of the powder which you are going to coat. So in this particular plasma zone, you basically feed the material in the form of powder, and then subsequently it is sprayed onto the surface of the substrate. Or so this is how plasma spray operation or spray coating is carried out. So in plasma spraying, by plasma spraying you can coat any material of your choice because it is having very high melting temperature. But plasma spraying is not applied for the melting of the low melting material, particularly zinc and aluminum. And also you can, so think of the particular metallic material having no melting point, polymeric material, those materials cannot be deposited by this plasma spraying. But high melting point material, ceramic material, sulfate, they are coated by this plasma spraying. So little bit advanced of plasma spraying is a reactive plasma spraying. So when you are interested to metal matrix composite of or any ceramic coating, you can have a metal frequency powder, and you can also flow nitrogen oxygen as a reactive gas. So you will find the inside that chamber there will the reaction, and then formation of the ceramic particle metal matrix composing and that get deposited on the surface of the substrate. Okay, so this is a very new form of deposition actually. So now if you think of the process parameter, this is not nothing but the nozzle to work distance, then powder size and type, then points of the powder introduction, arc current and voltage, type of plasma gas which you are using, then particle carrier gas type and particle powder flows. These are the different parameters which basically play an important role jointly to determine the coating quality. So this is about the today's lecture. Thank you.